All right, so in dynamics questions, it's only a matter of time before things start running into things. So here we have a particle A with this vector equation, and particle B with another vector equation. And if these particles collide, determine when they collide. Okay, so just before we get started, let's take a look at what it actually looks like. This is particle A with that vector equation. This is particle B with, let's take a look at the vector equation, this vector equation, and we're at time 0 right now. So if I move our time slider a little bit, we can see our vectors, we can see our points moving closer together, and we can see a collision taking place about there somewhere. So it looks like at about time 3, we're going to see a collision. So now that we know what this looks like, let's just see them move a bit quicker. Boom, and then sort of fly away from each other. So there's a single point where they're going to run into each other, it looks like. So let's determine this algebraically rather than using technology to help us out. So for two things to collide, there has to be that for two particles in two-dimensional space to collide, their I coordinates and their J coordinates need to be identical. In other words, for these two things to collide, it's their position in horizontal space needs to be the same. They need to be lined up in horizontal space, and they need to be lined up in vertical space. They need to have the same X and Y coordinates, essentially. So if we go back here, that means that 8 minus t would have to equal t plus 2. Because this I is like our X, it's our horizontal coordinate. So there's equation 1. But it's not good enough for the two particles to just line up horizontally. Because just because they're lined up horizontally doesn't mean that they're going to hit each other. They could be one here, one here, one here. They're lined up horizontally, but they're not lined up vertically. Two planes flying overhead, they're lined up, but one's above the other. So we'd also need them to run into each other here. So we'd also need to say that 8 minus 4t plus t squared is equal to 2 minus 2t plus t squared. So if the t value here is equal to the t value here, then they collide at a specific point. Now, if you solve this and you get two t values, and you solve this and you get a t value, but none of them line up, then that just means that at some point they were lined up horizontally, at some other different point they were lined up vertically, but they were never lined up horizontally and vertically at the same time, which is what it would take for two things to collide. So if you solve this, you're going to get t equals 6. No, you're not. You're going to get t equals 3. You can run through that if you want. If you solve this one, it looks like you're only going to get one answer here. Negative 2t plus 2t, 2t there. It's going to be 8 minus 2 is 6. Well, you're going to be t equals 3. All right, so that time equals 3. They're lined up horizontally. They're lined up vertically. So they're going to collide. Determine when they will collide at time equals 3. Okay, what are the coordinates of the impact point? Okay, so coordinates of the impact point. Really, we're saying what will the I component be and what will the J component be of our impact point? So I can go right. I can sub it into either one of these. So I can say particle A at time 3. Really, the question I'm asking is where will you be? So you'll be at 8 minus 3 I, and you'll be at 8 minus 4 times 3 plus 3 squared j. So that's going to be 5i and then it's going to be 5J. So the coordinates of my impact point are 5, 5. Let's see if my GeoGebra thing agrees with that. Okay, 5, 5. Yep, looks like that's where they're meeting. Okay, what else did I have to work out here? So I'll just put our coordinates here at 5, 5. And next it's find the Cartesian equations of the trajectories of the particles. So we've done this before, so we need to do it for both of them. So we'll need to do it for this first particle here. So we know that the x coordinate of this one is 8 minus t, and we know that the y coordinate of this one is 8 minus 4t plus t squared. And for this one, we know that the x coordinate is equal to t plus 2, and we know that the y coordinate is equal to 2 minus 2t plus t squared. So now we can just, if we call that equation 1, that equation 2, and this is the other equation 1 and the other equation 2, we can sub in whatever values we need to sub in here to get rid of our t value. So this is going to be, so t is going to be equal to 8 minus x. So I can sub in 8 minus x for t in equation 2. So y equals 8 minus 4, 8 minus x plus 8 minus x squared. Then I can tidy up that equation. I should get a nice little quadratic come out of it. Y equals x minus 6 squared plus 4. I have missed out some little expanding there, but there's our basic equation there. And then you can do the same here, obviously. You can sub x minus 2 into equation 2. So y equals 2 minus 2 times x minus 2 plus x minus 2 squared. And again, we can probably just jump to an answer here. Something like x minus 3 squared plus 1, I think. All right, so there's our two quadratic equations. And if I jumped back to GeoGebra real quick, if I put a trace on A and B, put a trace on these guys, the equations that they're tracing are the equations that we found. Okay, and then use a graphics calculator, verify the coordinates of the impact point. You guys can do that, so I'm not going to muck around with it. Shove that into your graphics calculator, shove that into your graphics calculator, and see where they meet. I would bet a lot of money that they will meet at 0.55. All right, that's it.